Welcome to Hardly, where each book is distilled into a chronological story, offering you a special journey in just minutes. Let's talk about Brian Kernighan's UNIX, a history and a memoir, in which we probe into how a simple, collaborative environment can unexpectedly spark some of the greatest technological innovations, even when resources are scarce. Brian W. Kernighan received his BAsc from the University of Toronto in 1964 and a PhD in electrical engineering from Princeton in 1969. Don't go away. Hardly, the editor, will be right back with the story. It all began at Bell Labs, an unlikely breeding ground for one of the most influential technologies in modern computing. The year was 1969, and amidst the sprawling halls of this telephone research hub, a small group of researchers worked with what little they had. Bell Labs itself was a unique environment, teeming with brilliant minds who were given the freedom to chase curiosity, even if the results weren't always immediately clear. Among these visionaries were Ken Thompson, a computer scientist with a passion for systems, and Dennis Ritchie, whose brilliance lay in programming languages. Their collaborative work would set the stage for UNIX, but no one knew it yet. At this point, the labs had just pulled out of a massive project called Multics, an overly ambitious operating system that attempted to do too much, too soon. When the project was shelved, Thompson found himself staring at a seemingly outdated DEC PDP-7, a machine relegated to the corner of the lab. Rather than letting the PDP-7 gather dust, Thompson saw an opportunity. He had a simple idea, a modest operating system that could do a few things well without the complexities of Multics. In 1969, Thompson began working on what would become the first version of UNIX. His vision was practical and stripped down, just a way to run programs and manage files. He worked tirelessly, often alone, in the quiet attic of Bell Labs. But his solitary efforts weren't isolated for long. Ritchie, intrigued by Thompson's progress, brought his deep knowledge of programming to the table. Together, they began shaping UNIX into something that was not only functional, but elegant in its simplicity. As Thompson later recalled, "At some point, I realized that I was 3 weeks from an operating system." By 1971, the first edition of UNIX was complete. It was used for practical tasks like patent applications, a quiet but critical moment in its early life. UNIX didn't explode onto the scene in those early days. Instead, it quietly proved its worth by being reliable and versatile. It wasn't flashy, but that wasn't the point. UNIX was lean, effective, and crucially, it was something the developers themselves wanted to use. They had created a tool that solved real problems, born from necessity and driven by personal curiosity. Now, this section's point of view emphasizes how collaboration in a flexible, intellectually rich environment can yield remarkable results. With limited resources and no grand expectations, Thompson and Ritchie turned an overlooked piece of hardware into the foundation of something that would change the world. The modest beginnings of UNIX remind us that innovation doesn't always start with big budgets or grand visions. It often begins with curiosity and perseverance in the face of constraints. As the story of UNIX unfolds, what started as a humble project will grow. In the next phase, we'll see how this once small system begins to expand, evolving in ways even its creators couldn't have foreseen. The stage is set for UNIX to reach new heights as more features are added and its influence spreads far beyond the confines of Bell Labs. As the 1970s unfolded, UNIX wasn't just surviving, it was thriving. By 1975, it had grown well beyond the bare-bones system Ken Thompson and Dennis Ritchie had initially crafted. At the heart of this transformation was an unlikely but powerful ally, the C programming language. Originally developed by Ritchie, C was a game changer. It allowed UNIX to be rewritten in a higher-level language, making the system far more portable. Suddenly, UNIX wasn't tied to any specific machine. This flexibility would be one of its defining characteristics. By the mid-1970s, UNIX had reached its 6th edition, a pivotal moment. It wasn't just a lab project anymore. Universities were beginning to take notice. This newfound interest wasn't because of flashy marketing or corporate backing, it was because UNIX was a system that programmers loved. It was elegant, simple, and thanks to the introduction of tools like the Bourne shell, it could do more with less. The tools weren't grandiose, but they were effective. UNIX developers believed in small, modular utilities that did one thing well, an idea that would shape computing for decades to come. Then came one of the most important innovations in UNIX's evolution: pipes. Doug McIlroy, a key figure in the UNIX community, proposed the idea that programs should be able to work together easily. By connecting programs through pipes, users could combine simple tools to accomplish complex tasks. This seemingly small feature changed everything. Suddenly, UNIX wasn't just a system for running isolated programs, it became a platform for creativity. You could build new tools on the fly by linking existing ones, a concept that still resonates in modern programming. As UNIX grew in power, it also grew in reach. Universities began using it in their curriculum. The Programmer's Workbench, introduced in the mid-1970s, made UNIX more appealing to researchers and engineers who needed a reliable environment for software development. And by 1979, with the release of the 7th edition, UNIX's portability reached new heights. The system was no longer confined to Bell Labs. It was spreading through licenses to universities, fueling an entire generation of programmers who would go on to shape the tech landscape. UNIX was becoming more than just an operating system. It was becoming a philosophy. Write programs that do one thing and do it well, as the UNIX philosophy urged, and this mindset attracted a community of users and developers who shared a passion for simplicity and efficiency. The beauty of this period wasn't just the technical innovations, it was the collaborative environment that fostered them. Developers like Thompson, Ritchie, and McIlroy weren't competing. They were building something they believed in, something they used every day. This organic growth, from the lab to the world, was based on the system's merits, not flashy presentations or corporate backing. As we transition to the next phase, the seeds of UNIX's commercialization begin to sprout. The system that started as a small lab project was now becoming too big to ignore. Companies and institutions outside of academia saw its potential, leading to tensions and power struggles over ownership and direction. UNIX would soon enter a new stage, one marked by commercial interests, conflict, and a legacy that would extend far beyond its original creators. As UNIX matured in the late 1970s, its influence expanded well beyond the walls of Bell Labs, drawing the attention of companies eager to capitalize on its growing reputation. By 1980, UNIX had started a journey that would take it from the academic and research communities into the corporate world. The commercialization of UNIX was inevitable, but it came with its own set of conflicts, most notably the infamous UNIX wars. As UNIX gained popularity, AT&T, the parent company of Bell Labs, realized that they had a valuable product on their hands. By 1983, AT&T had begun marketing UNIX under the brand UNIX trademark. However, this move sparked tensions. Universities and developers who had helped shape UNIX's early identity felt it was slipping away into the clutches of corporate interests. AT&T's decision to assert control over the system led to a fracture within the UNIX community, giving birth to the so-called UNIX wars. During this time, various factions emerged. One of the most significant was the rise of the Berkeley Software Distribution, BSD, which had been adapting UNIX for their own use since the late 1970s. BSD developers, primarily from the University of California, Berkeley, saw UNIX as a platform for innovation, contributing tools and features that expanded its capabilities. But as AT&T pushed forward with commercialization, legal battles ensued, with BSD and AT&T clashing over intellectual property and control. While the UNIX wars raged in the corporate and academic world, other movements were brewing. In 1991, Linus Torvalds, a Finnish student, developed Linux, a UNIX-like system that was free and open to all. Linux would go on to become one of Unix's most significant descendants, widely used in servers, mobile devices, and supercomputers. Meanwhile, back at Bell Labs, Plan 9 emerged in the late 1980s as an attempt to rethink Unix for the future, though it never gained the same traction. Amidst the conflicts and innovations, Unix's core principles endured. Even though legal battles and commercialization efforts created division, the system's design philosophy, simplicity, modularity, and portability continued to influence operating systems and programming practices across the globe. Its descendants from BSD to Linux and its indirect influence on systems like macOS make Unix's legacy undeniable. As commercialization settled and the Unix wars came to an end, the system had achieved a level of ubiquity that no one could have predicted. It wasn't just an operating system anymore. It was a blueprint for how to think about software development, system design, and even collaboration in the tech world. The story of Unix is a story of adaptability as it evolved from a modest lab project into a global force, all while staying true to its core philosophies. As we look back on Unix's journey from its origins to its commercialization, it becomes clear that innovation and legacy don't always follow a straight path. Unix's influence didn't end with commercialization. It merely changed forms, giving rise to new systems and ideas. A modest project at Bell Labs, initially led by Ken Thompson and Dennis Ritchie, grew from a small operating system into a global force because of its simplicity and collaborative environment. Unix's core design philosophy, small tools, modularity, and portability allowed it to spread across universities, leading to key innovations like the C programming language and pipes. Despite commercialization struggles, its open nature fueled the rise of systems like Linux, shaping modern technology and influencing everything from servers to smartphones today. As the editor of Hardly, through learning these stories, we are reminded that the future of technology lies not just in invention, but in fostering an open, collaborative culture that allows ideas to thrive and transform, sometimes in unexpected ways. As we come to the end of this journey, the key argument that a simple, collaborative environment can lead to groundbreaking technological innovations becomes even more apparent. The story of Unix is a testament to this idea. While it began in the modest confines of Bell Labs, its growth and eventual commercialization show how an open culture of creativity can result in lasting impact. One memorable story that highlights this is from the mid-1970s, when Doug McIlroy introduced the concept of pipes. At the time, programmers were wrestling with how to efficiently connect programs. McIlroy, who believed in the power of small tools working together, suggested a simple solution. Let the output of one program feed directly into the input of another. This idea, embodied in Unix's pipes mechanism, allowed users to combine tools to perform complex tasks without writing new software. McIlroy's pipes became one of Unix's defining features, emphasizing the power of collaboration over complexity. It's a perfect example of how an open, idea-driven environment at Bell Labs led to something innovative and practical that programmers still use today. Unix's legacy isn't just about the code. It's about fostering the right environment for creativity and letting ideas grow organically. By understanding its history, we see that the best innovations don't always come from big plans or corporate strategies, but from environments that encourage exploration and collaboration.